Good morning, dear students. I hope everybody is fine and doing their studies. We have completed the course of the industrial chemistry paper. Now we are going to start the revision, what we have read in the classroom. So I'm starting the revision part from the unit 1, that is water and its treatment. So let's start our unit, the water and its industrial application and the treatment. So first we go for understanding the introduction. As we all know about the water. The water is nature's most abundant and the useful compound, having a common general formula H2O. Without that, the survival of the life of the living things as well as the living beings, including us, cannot be possible. It is called the universal solvent because the water can dissolve any of the impurities very easily. It is polar in nature. Understood? Without water, we cannot think about the survival of the life. For the existence of the plants and the animals, including us, the water is the most essential part. And what is the scenario of the water on the earth? Our earth is a blue planet, of which 3/4 portion is covered with the water. And about 97% of the water is a seawater, salty water. And out of 3% which is left out, if it is 97%, if we are assuming that the 3/4 portion of the earth having the 100% water, out of that 97% is salty water and remaining the 3%. Out of that also 2.6% is covered in the glaciers, polar ice caps. Understood? So if a 2.6% is covered in such kind of polar ice caps or glaciers, so only how much it remains? It remains only 0.4, means less than 1% of the water is available for our ready use. This is very important to know the scene of the amount of the water we are having in use. So it is very essentially required to use the water efficiently and economically. As previously I have said that the main purpose of this unit is to remind the water importance and how to use the water economically and efficiently. That's the main thing, whether the water is used as an industrial purpose or whether we are using for the domestic applications. The water, besides the common application, have a wide range of the industrial applications, in which the main engineering application is the boiler. So that is the main thing here of the scope and objective of this unit. We are focusing of the water to the main application, to the specification required, that is boilers here, because boiler is one of the important application used for the steam generation. And for that, which kind of water is required? Almost zero hardness, 0 ppm, 0 milligram per liter, almost 0 ppm hardness is required. Alkalinity of water should be less. The physical impurities, specifically the oil-like impurities, cannot be there if we are using in the boilers, and the dissolved gases like oxygen and carbon dioxide, these gases are also not required in the water when we are using to the boilers. So we are focusing to the main application, engineering application in this unit. So which kind of water is required for the boilers? It is almost zero hardness is required, alkalinity is less. You have to remind again, physical impurities, specifically oil-like impurities, and the dissolved gases content should be low. So for this specification, the water is analyzed and treated as per requirement. How the analysis takes place, which important properties are responsible for that, we learn in this unit. So one is the important engineering application we have to focus, and the second is municipal water treatment, where we go for using the water for the domestic application, mainly drinking. So various steps are involved in the municipal treatment, which is main means for the drinking water, and we go for understanding which kind of water is required for the drinking purpose. So that is the main domestic use of the water, that is drinking. So municipal treatment is based on this application, domestic application. As we all know, besides the common applications, the water has a variety of the industrial application also. If we see the common application, the drinking, including the drinking, there is washing, bathing, cooking, besides the drinking, I said. And the industrial application is having a wide range. As you are able to see, the textile industry, the laundries, in the paper industry, the boilers, we have focus, the beverages, food products, then pharmaceutical industries, dairies, sugar industry, many more applications are there of the water industrial purpose. So each one of the industrial application of the water has its own requirement, and which is called a specification. You have seen just before we are talking about the engineering application boiler. So for that, which kind of water is required? It should contain almost zero hardness. The alkalinity should be less. It should be free from the physical impurities, and it should be free from the dissolved gases like oxygen, carbon dioxide. Same if we are talking about the textile industry, its requirement is different. The boilers requirement is different. For the laundries, requirement is different. For each one of the industrial application, we have a different requirement. For example, the textile industry, for which kind of water is used in the textile industry? It should be soft, means hardness should not be present. It should be free from the organic matter impurities, the plant and animal remains. The water used for the dyeing, because in the textile industry, the water mainly used for the dyeing purpose, color. So it should be free from the iron, heavy metal, manganese, even some kind of color. It should be free from. It should be checked before. Because if it is there, it causes the uneven dyeing. If the hard water is used, it decreases the solubility of the dyes, thus affect the uniform dyeing. So it's a main thing here to be seen in the water when used in the textile industry. So these are the specifications required for the textile industry. If we see the laundries, the water should be soft for the laundries. If the hardness is there, the cleaning doesn't take place. It should be free from again the heavy metal and manganese, iron, which impart the yellow or the gray shade to the fabric. The cleaning, for the cleaning purpose, the industry, the laundering is main application. So there, if it is imparting some color, so it is destroying the fabric. If the hard water is used, it will consume more soap, means the cleansing action is affected. Now, if we see about paper industry, the water should be free from silica. Again, you have to know about if we are using the water in the paper industry, it should be free from silica because it produces the cracks in the paper. And it should be free from the alkalinity. These are the parameters to be seen when we are using the water in the paper industry. It should be free from silica, it should be free from alkalinity, because alkaline water consumes alum and increases the cost of the production. Water should also be free from hardness because it increases the ash content of the paper. If hardness is higher, when we just burn the paper, the ash content become more, which is not so good. It affects the quality of the paper. And the same we are repeating here. The boilers, the specification is almost zero hardness, the alkalinity is less, dissolved gases content should be low, physical impurity should be less. So these four specifications you have to remember always. So the next application is beverages or the food products. We always use preservatives to prevent of spoiling of the food. So water should not be alkaline in that case because it destroys the taste as well as it tend to neutralize the fruit acids present in the preservatives. So it spoils the food. The next is pharmaceutical industry. For that, which kind of water we go for using? The water should be ultra pure. It should be colorless. It should be odorless, tasteless, free from organic impurities, disease-producing microorganisms, or the pathogens. In the dairies also, ultra pure water is required. In sugar industry, the water should be soft. If the hard water is there, it mainly contains the sulfates, nitrates, which are used in the sugar refining. It results in the formation of deliquescent sugar. So it affects the quality again. These impurity also cause the difficulty in crystallization of the sugar. So in the refining process, in the crystallization process, it affects if the hardness is there. So this type of water should be soft for the sugar industry. Now we see from where the water comes, various sources of the water with its quality. Then only we can understand which kind of water it is and how we go for using in the application. So we can divide the sources of water into the four main types. The one is surface water. The second is rainwater. The third is underground water. And the fourth is seawater. The seawater, you have seen the maximum amount of the water, 97% is of seawater. So if we see the other sources, surface water, which is collected in the form of rivers, lakes, streams, ponds. The rainwater is the purest form of water, but it cannot be collected and used directly because it is so expensive to collect directly and its use. The underground water, which absorbed through the soil and collected around the rocks inside the earth. So surface water can also be divided into flowing water and still water. The flowing water, which continues go on flowing, rivers and streams, and still water is the standing water, which is still lakes, ponds and reservoirs. The underground water can be divided into three, like springs is one kind of underground water, the tube wells, They are stored inside the earth. So we go for comparing each source of the water and see its quality. The surface water, it is available as the runoff from a catchment area during the rainfall. And this runoff flows either into the streams or into the undrained lakes. It can be divided into two types, the flowing water, the rivers and the streams, and the second is still water, the lakes, ponds and reservoirs. Previously only in the flow chart we have seen. Now, is there any difference between the flowing water and the still water impurity level? Yes. Because in flowing water, it contains the major impurity in the form of dissolved minerals of the soil, such as the chlorides, sulfates, bicarbonates of sodium, calcium, magnesium, iron. So the dissolved minerals are mainly present in flowing water. It also contains some amount of the organic matter which is derived from the decomposition of the plants and the small particles of the sand and the rock. Means a less amount of the organic matter is present in this type of water. The amount of the dissolved impurities in this kind of water depend on the contact of the water with the soil, and its composition is not fixed because it is flowing, and the impurity level, either the dissolved minerals and the organic matter, varies. It is different. It depends on the contact of the soil. It depends on the area of where the impurity levels are different. So it depends on that. Now second, the still water or the standing water having the less amount of the dissolved minerals and have the high quantity of the organic matter because it is still water and it has the constant composition. It is available only those town or cities which is situated near the lakes. So the lake water or the pond water where the area where there nearby the lake and pond is there, it is available in that town or the city. The rainwater is the purest form of water, but during the downward journey through the atmosphere, it dissolves many of the atmospheric gases like sulfur dioxide, carbon dioxide, nitrogen dioxide, so it become impure. When it come downwards, it come in contact with the atmospheric gases and it can dissolve various gases, so it become impure. It is very expensive to collect this water and supply it. And which kind of water is underground water? It is the largest available source of the fresh water which is deposited inside the earth underground. It is very clean due to the filtering action of the soil. We can easily directly drink this water. It contains the dissolved gases and the dissolved salts. What kind of impurities are present in it? The dissolved gases and the dissolved salts. Water is free from the organic impurity. That's why we can easily drink it. The water contains more dissolved salts. The last source is seawater. As we all know, it is the most impure form of the natural water. Why it is highly impure? Because all the flowing water join the sea and its impurity in the sea, and also due to the continuous evaporation of the water from the surface, the dissolved impurities is increases. The sea water contain an average 3.5% of the dissolved salt, out of which 2.6% is of NaCl, and we are working on it to have the process to remove this amount of the percentage of the salt and use the seawater in the application. But except the cooling, we are not having any other application of the seawater. Other salts presents the sulfates of the sodium, bicarbonate of the potassium, magnesium, and the calcium. Now, by understanding the various sources of water, and we have seen which kind of the impurities present in the water, we can classify the impurity in the water sample into three main types. The one is physical impurity, the second is bacteriological impurity, and the third one is chemical impurity. The physical impurity can be divided into two types, the suspended impurities and colloidal impurities. The suspended impurities means size of the particles are larger. That's why they are suspended in the water, and colloidal means the size is smaller. It is not too much small or too much large. It is in between the small to the large, that is colloidal particles, and they also included in these impurities. Fine impurities. Bacteriological impurities including the bacteria, fungi and algae, and the chemical impurities involve the dissolved gases and dissolved salts. The suspended impurities may be inorganic, maybe the particles of the clay, sand, and the organic like waste of the plant and the animal products. The colloidal impurities, the product from the organic waste, it is having the fine size, finely divided silica, come in the category of the colloidal impurity. Here we have given some examples. And bacteriological impurities, the disease producing, you have seen the bacteria, fungi and algae all come in this type of the impurity, which are mainly considered as the organic impurities. The chemical impurities come in the form of dissolved salts, and which may be organic and inorganic like chlorides, bicarbonates, sulfates, carbonates of calcium, magnesium, iron, manganese, aluminium, as well as the oxygen, carbon dioxide, these gases. So we have revised the first part of this unit with the introduction of the water. Then we have discussed the various applications with the specification, the various sources of water and the impurities present in the water. In the next lecture, we are going to revise the main property of the water, that is hardness. Till then, thank you and take care.